Hello, my name is JP Harms and I am a computer science graduate student at the University of Louisville. This is my graduate project in the field of artificial intelligence and machine learning. DeepSpace, a journey intertwining machine learning, space systems, and video games. The goal of DeepSpace is to show the capabilities of simulating real life within a video game design engine and how they can be beneficial to advancing practical machine learning applications. Here's our agenda. The agenda for this presentation is as follows. The introduction, state of the art, we're going to show the system description, the implementation, the analysis of our results, the societal impact of this project, and the conclusions and some future work ideas. I'll also be providing the GitHub repository link. The central focus of this project was to portray interdisciplinary applications of machine learning and how they can be utilized in sync to create something amazing. Some examples of these applications include the field of computational biology, where explorers are using deep learning and neural networks to create their own novel drugs and molecules to combat infectious diseases. In the medical field, there are plenty of companies who are currently using machine learning and understanding X-ray images. This project grew inspiration from the 2020 Summer NASA Science Mission Directorate Entrepreneurs Challenge, where NASA requested for physics-based transfer learning artificial intelligence applications in the space industry. The interdisciplinary application being explored in this project intertwines the fields of space systems, video game design technology, and of course, machine learning. Through the Unity game design engine and Unity ML Agents framework, I will be exploring how to simulate space and the usefulness of such a simulation in the real world. There is quite a history of research groups and companies harnessing the power of machine learning-powered artificial intelligence agents. These agents are essentially computer AI brains that are capable of mastering skills that would take years for a professional player to hone. The AI agents listed here are just 3 of the recent breakthroughs in this technology. For instance, AlphaZero. It is a computer system AI that was trained to be professional at chess, playing some of the most hardcore chess players across the world. AlphaStar. This utilizes multi-agent reinforcement learning to become a Grandmaster level player in StarCraft 2. If you're a gamer, that's pretty awesome. OpenAI 5. This is a Dota 2 AI that's trained for over 10,000 years of game time. It played against itself this entire time. That's incredible. The case study of this project included the following steps. In this project, I will be developing a space simulation environment in the Unity Game Engine Design Studio. I will be designing a training configuration of a space mission, where our space shuttle must be capable of traversing a randomly generated space map to reach a space station. Then I will be building an AI agent in the Unity ML Agents framework that can fly through space and detect/avoid these obstacles. Finally, I'm going to train this agent on the space simulation environment to create an AI brain that is capable of completing the mission to reach the space station. Alright, now to the juicy parts. This screen is providing a high-level roadmap into the system's description utilized in building this experiment. Firstly, the Unity Design Studio is free software that will be used to create the space environment simulation scene that our agent will be training on. Speaking of it, the agent in the simulation is our Warrior Space Shuttle in the bottom left-hand corner. The space shuttle is powered through various C# scripts that were designed to empower the spaceship with movement in space, the reward structure and observations, and additional machine learning configurations. Some of these are configured in a separate .yaml file that can be fine-tuned during the training process, shown in the middle of the screen. Finally, a source score screen was built into the space environment to provide feedback on how well the space shuttle is performing. Now, let's take a look at that environment. Here it is. The space environment scene that I built in Unity includes several different aspects. First off, the space shuttle agent is spawned at a starting point. The goal of our little spaceship is to fly to the space station the fastest it can, while avoiding any obstacles in its way. Speaking of obstacles, asteroids are randomly generated on the environment during each episode to provide randomness to the scene and to the learning. The score screen mentioned earlier includes the number of runs the spaceship has made to reach the target and the score for how many of those runs it actually made there. The agent in this experiment requires 3 key design features in order to be successful in deep reinforcement learning. Firstly, the space shuttle must be able to observe its environment at every point during the run. This agent is equipped with 3 raycast sphere cones that project a certain distance from the center of the space shuttle. These raycasts detect obstacles and boundaries and report that back to the agent. The agent is also capable of measuring its current velocity, position, and rotation. It can also measure its current distance away from the space station. The agent also must be able to take actions upon recording one of these observations, or all of them. As expected, this space shuttle's only actions are to accelerate in the forward direction or turn. This observation plus action combination make up what is called an agent behavior. Finally, the agent possesses a reward structure that is provided to the agent after enacting a behavior. The agent receives a small negative reward for every time step it is flying. This teaches the agent to fly quicker. It is provided a large positive reward for reaching the target and a small negative reward for colliding with an asteroid or a boundary. The final reward it receives is a scaled reward based off its current distance to the space station. Alright, this experiment restarts a run either when the agent makes it to the space station, hits a boundary, or collides with an asteroid. With the power of Unity, I duplicated the space environment training scene 6 times. This means 6 environments, 6 agents, all running simultaneously at the same time and feeding into just one neural network. Okay, now let's watch this space shuttle train. You'll see on the screen here, this is a screen capture during the actual training time. Those little red lines are actually the space shuttle. It's sped up super fast, that's how Unity works. You'll see it flying through and you can see all the different asteroids randomly generating every time the agent ends a simulation. You can also see the space station in the back here. You got the score screen. Now you see the big negative up there and then the number of runs. So it's obviously not flying towards the space shuttle. This means it was early in the training. Now you can see it getting a little bit better. Some of those are flying actually to the space station, which is pretty incredible. You can see them also resetting pretty fast there. Now you can see our score. That's a little bit better. It's not all negative. We're training better. The space shuttle is getting a lot smarter, which is pretty amazing. Now we're actually at positive numbers here. This was actually probably 8 hours or so of training at this point. The space shuttle is able to do it. Okay, now we've finished training. Now we're actually going to take a look at, the space shuttle brain. So basically how this works is the spaceship is trained for over 8 hours straight. After completing training, the neural network can be surgically extracted from the training results in the form of an AI brain, basically pulled right out of the training. This brain can then be injected back into Unity to run the simulation again, only this time it is making its own decisions from the neural network. Okay, now let's actually see that AI in action. Okay, so you can see it's a lot slower now. This is because it is running in real time. It's not sped up from training. You'll see the agents kind of flying around, meandering. Our score is 2 for 2, so we're doing really good so far. I'm going to show a wide angle view. You can see all the agents with their AI brains running into the space station. You can see them kind of looking around, flying around. This is basically how it's projected the best to go. All right, let's zoom in. Here we go. Look at that positive number up there. It's not perfect, but heck, this spaceship is actually flying towards the space station. Let's get a little zoom in. He's flying a little crazy there, but he's doing it. Let's take a look at this one. You can see him flying. He looks like he's going towards the space station. Let's see if he actually hits it. Still have a pretty good score up there. Trying not to hit any asteroids. Let's take a look at this agent. You can see him. He's pretty much at the end, and he's flying. Boop, hit it. Pretty incredible. So reset, and now it's going to try to do it again. So this is our trained brain running. This isn't training. This is a trained brain running on the simulation. Finally, let's take a look at what the spaceship sees. I don't know about you guys, but I don't know if I'd want to be on that spaceship. You can see this is definitely a computer running this. Obviously, with some more skills, some more limitations of the rewards, you could probably teach the space shuttle to stop making all of its passengers throw up the entire time it's flying. Better luck next time, space shuttle. But you know what? At least you're making it to the space station. Okay. Now, sorry about that. Let's look at the actual results. The 4 graphs provided here are the cumulative reward over the course of training, the average lengths of the episodes, the value loss, and the entropy. The cumulative reward steadily increases during the training, showing great progress. The episode length grows in time, but then evens out over the course of training. This is expected since the agent does most of its learning up front. The rest is pretty much fine-tuning. The value loss even out over the course of training, which is expected as well. You'll see the sample screenshot, the score screen in the center. This is of our trained AI brain flying the simulation. While, it's not exactly perfect, the brain is completing over half of the runs successfully. These are great results. With much more training time, much more than 8 hours, it can be assumed that this AI might be able to 100% that number. 2 major takeaways of this experiment are, with improvements, this AI brain could possibly compete with trained space shuttle pilots. Unity and ML Agents frameworks is capable of mimicking a detailed space environment. While this experiment was really fun to build, it also rose some ethical questions to ponder on. Could a trained neural network deem astronauts not required to survive the mission for it to reach the reward? Is it possible to certify a machine learning AI to carry human life into the cosmos? You know what? What happens when this technology becomes militarized? In conclusion, this was an excellent experiment on the interdisciplinary field of machine learning, space, and gaming development engines. It is just the beginning in exploration of using simulation technology to provide a graphical training environment for AI. I've identified several types of future work that can be pursued at the completion of this experiment, including utilizing an LSTM network to add memory saving during training. You could also utilize a thing called curriculum training to challenge the AI as it gets better during training. You can add greater detail to the space environment, such as planet gravity, black holes, and space dust. You can also expand the spaceship's capabilities and actions, such as adding shields, hull health, or giving it some blasters to take care of those pesky asteroids. You can also increase the simulation, make it further, and build takeoff and landing missions, and train a new AI brain for each of those executions. I want to leave this project with the following 2 quotes to spark interest in machine learning. Said by Steve Jurvetson, a board member of SpaceX and Tesla. Machine learning allows us to build software solutions that exceed human understanding and shows us how AI can innovate every industry. And by our beloved Stephen Hawking, a theoretical physicist. He said, "Success in creating AI would be the biggest event in human history. Unfortunately, it might also be the last, unless we learn how to avoid the risks." To see how this Unity project worked and view the code, follow the GitHub link provided to the source code repository. Feel free to download and improve upon this project. Alright, thanks for watching. My contact info is the bottom if you have any questions, and remember, to infinity and beyond!